Hey programmers, Alvin here. Right now I want to go over a JavaScript solution for this leaf list problem. So hopefully you watched the approach video, because if you did, you'll know that we're going to solve this when using a depth first traversal. And I'll show you it iterative and recursive, of course. Let's start with the recursive way. So they tell us in this problem that we can't assume that the input tree is going to be non-empty, so I should guard up front, right? If the root is null, then just return all of the leaves in that empty tree. And I know that there are no nodes or no leaves in that empty tree, so just return an empty array. Now I can start my general algorithm, right? Depth first requires a stack, right? Whether it's the recursive call stack or your explicit, like array stack. So I'll say const stack starts with just the root node. And then my main loop sounds something like, while your stack is not empty, keep on removing things from the top of the stack. And now in a single iteration, what I do is remove the top of the stack. So for me, that's stack.pop. And that'll give me my current element. So I'll say const current. And then from there, for now, I'll just look at the children if they exist, and I'll add them to the stack, just laying down the foundation of a depth first traversal. So I'll say if my not stack, but if my current.left is not equal to null, then it means my left child exists, so add them to the top of my stack, stack.push current.left. It's just symmetric for, of course, the right-hand side. Something like this. But I need to stay super aware here. We mentioned that in this problem, we want to make sure that the order of the leaves flows from left to right. In other words, you want definitely DEF in your output and not FED, right? That would be bad. And so, although I'm making a depth first traversal, by manipulating the order of like these two lines, that will decide whether I go to the left first or I go to the right first. And what I want to do is actually order it like this. So if I push my right child and then my left child, that means the left child's at the top of the stack for the next iteration. If they're on the top of the stack, then I know that they're going to be explored first. So writing it in this way would give me a left to right traversal in the case of an iterative depth first. Nice. And then from here, now I just need to consider, all right, whenever I find a node that is a leaf, add it to some array that I'll return. So let me get that started up top. So I'll create an array of leaves, starts empty. I'm going to return it at the end, of course. But where should I actually check for these leaf nodes? My favorite place to put like the node processing logic in an iterative traversal is to do it whenever it leaves the stack. That way I don't have to duplicate it for pushing children, right? So when something leaves the stack, I know that when it leaves, I will still get the correct depth first order. I'm going to check if this current node is a leaf. So programmatically, all that means is if the current's left pointer is null and current, I should say ampersand here, right? So logical and current's right pointer is also equal to null. So if it's a leaf, then what should I do? Well, just push that leaf's value into your leaves array. So for me, all that is leaves.push current, and make sure you actually put the value there. So current.val would be the move here. Awesome. I think let's give this a run, see what we get. This code looks like a pretty straightforward O of n times solution, right? Because every node enters and leaves the queue once. And definitely the space is just going to be the leaves array, which is definitely n, and also I guess the stack, right? Doesn't change the space complexity though. All right, for the culture, let me show you the recursive version of this. So it's going to be almost the same story, just reframing all of our logic recursively. So what I would do here is create like a helper function. I'll call it like fill leaves, and this would actually do the recursion for me, just because I like to keep things separate here. So I'll take in root, and I'm going to accept also by reference the collection where I want to accumulate all of my leaf nodes. So over in my main function, I'm going to create that collection. So I'll say const leaves equals an empty array. And I'm going to invoke my helper function. So fill leaves is going to do the recursion. And if I pass in the initial root, as well as the collection of leaves I want it to fill up, it should just do that for me. Then at the end, I should just return leaves, right? So I'm passing along this array by reference. So this fill leaves function is actually going to mutate that leaves array and variable. So now I can just focus on writing the recursion here. Classic recursion for our depth first, right? Always handle the case as a base case if your root is null. So if root is null, then you can just return. I don't really want this fill leaves function to return any data that I'm going to use because I actually just want it to mutate this leaves variable. So beyond that, my recursive case might look something like this. Fill leaves of course, root.left, pass along the same leaves array, and same thing for your right-hand side. And what I also need to do is actually, as I traverse recursively now, check if my current root, if that's a leaf. If it is, then just add it into the leaves array. So what I can do is, if root.left is null and root.right is null, then root itself must be a leaf. So I can just take its value and append it, or push it into leaves. So leaves dot push, and I'm going to push root.val. One thing I want to be super sure of to do in this recursive code is make sure that it recurses down the left subtree before the right subtree. Since I'm writing this recursively, that is the case because I call fill leaves root left first before fill leaves root right. Right? So because I know how JavaScript evaluates code, before it ever hits line 19 and goes to the right subtree, it must have returned from traveling through the left subtree. So this seems good to go for me. All right, let's give this recursive flavor a shot. Awesome, and here we have another solution, recursive that is, for this leaf list problem. So I highly recommend you practice coding up both of these solutions. They're not long by any means. And once you're feeling comfortable, hop into the next problem. I'll see you there.